So where we left off yesterday, we were looking at definition of circles, and we already wrote all that down. So we talked about being all points on a plane equidistant from the center point. And the one thing that I wanted to add here, because we have our notation now, just under example / explanation, just add a circle is always named by its center point. Okay, so that's basically covers everything you need to know about circles. Parallel lines. I don't know where I left off yesterday. I was getting people to tell me their definitions. So I'm just going to start in the very middle group. And if you have your definitions from yesterday, you can just read me what you guys came up with. If not, you can just make up a definition right off on the spot, I guess. So middle group, what did you guys write down for the definition of parallel lines? And don't, what? They don't intersect. Okay, let me get one more definition because from you guys right there. Okay, that adds something right there. Well, I'm going to start with that first part. Two lines that never intersect. All right. Actually, sorry. There can be more than two parallel lines, so I'm going to put two or more. And I'm going to leave a gap right here. I'll get it straight eventually, but there you go. Two or more lines that never intersect. All right, now this is what a lot of people come up with as a definition. And you added something to yours. We'll come back to that in a second. But if you say two lines that never intersect, you know, the intention is that you're coming up with something like this, right? And assuming I'm holding them parallel, these, if I extended them forever, will never intersect each other. The problem with that definition is right here. Do these lines ever intersect? Are they parallel? No. So, you guys added something to your definition, and they're side by side. Now, we're going to basically incorporate that idea in there. So, your definition worked, but we're going to add a word in here to kind of get the same idea across. These are on the same plane. So, if you kind of look at it, you can see that you could draw a plane that passes through both of these lines. So, we're going to say that these two lines are coplanar. So, two or more coplanar lines. That's Planar. And this is just another way of saying on the same plane. Okay. So with parallel lines, let's go ahead and draw a diagram, and we'll talk about some of the important things that you need to think about parallel lines moving forward. So we'll assume those are parallel. I'm going to go with EF. I have to name these lines. EF and GH. Okay, now there will be times when you see lines that you might think are parallel, but they're really not. And so it can be tricky. I try not to do like trick questions like that too often, but it can come up just randomly from here and there. Anyways, one surefire way to know that two lines are parallel is if you see some notation on them. So if these two lines are actually parallel, you might see this notation. These big arrows pointing in the same direction, in the middle of the line. Now you could also have a diagram where there's lots of sets of parallel lines. Some running this direction, some running this direction, some running straight across. So in a diagram like that, you might even see these two being labeled with two arrows to distinguish them from the other. So just look out for that notation, and if you see it, then you know the lines are parallel. If you don't, they might still be, but you have to kind of get some other information on that. Okay, and the notation might be another way that you'll know lines are parallel. So we've got two lines here, EF and GH. I'm going to write them here in the notation. And maybe you don't see those parallel markings on the diagram, but maybe you see off to the side it says that EF and GH, and you see this notation right in the middle. That means that they're parallel. So if you see that, that's just as good. Now I will say one of the most common errors with this is people see EF as parallel to GH, and they think that they're congruent. And that's not necessarily true. So a lot of times they are congruent, sometimes they're not. All this tells us is that they're parallel to each other. Thank you. All right, so what we're going to do is I'm going to write out exactly what the translation of this notation is. And that says basically line EF is parallel to line GH. So that would be your translation for that notation on the left. So really important ideas that we're talking about right here, and I'll try and keep reminding you of these when it comes into play again, but it's good to be exposed to it right now. Let's think about perpendicular lines. I left off with you guys. I'm going to go to the back middle. What did you guys write for your definition of perpendicular lines?
Two lines that cross to create a 90 degree angle.
Okay, and that's, I think, good enough. I'm going to phrase it a little bit differently, but it's the same idea. So perpendicular lines, and if you didn't know this or forgot, there is this essential idea. Sometimes people just say two lines that intersect. They don't just intersect, they intersect, like Raynell said, at a 90-degree angle. So let me go ahead and write that. Two lines that intersect at a... And what's another name for a 90-degree angle? A right angle. At a right, I'm going to write them both down. So at a right, or in parentheses, 90-degree angle. Okay, and one thing that we didn't write in this definition is coplanar, because we don't need it. They are coplanar, but any lines that intersect, by definition, are coplanar. Because no matter what, I have two lines that intersect, I'm moving it around, I can't have them non-coplanar and intersect, if that made sense. So we just don't need to have that word in there. All right, so our diagram. These intersect at a 90-degree angle, so we want to show that. I'll have one going straight up and down. I have one going straight across, left and right. And I'll go ahead and call this one QR. You don't have to name it the same as me, but your choice. QR and ST. Okay, so just like parallel lines that have a notation, well, we don't know necessarily that these lines are perpendicular unless we have some kind of information that tells us that they are. And we do have some notation that shows us that this angle is 90 degrees. Does anyone remember what that notation is? All right, and you'll recognize it when you see it right here. If you ever see this symbol, it's just a box. All right, you've seen that before probably? So that's going to be your sign that it's a 90-degree angle. Okay, so the notation we're using here is going to look a lot like our parallel lines. I'll go ahead and write line QR and line ST. And the symbol we put in the middle is an upside down T, so it's showing perpendicular lines. And that means that line QR is perpendicular to line ST. Okay. So perpendicular, parallel, not too difficult of concept. The last one here, line segments. Let me see, well, first, are there any questions on what we've done? Okay. Back corner, tell me what you guys wrote for your definition of line segment. Okay, so if you remember, or you can, at the very least, let me see if you can do this. Can anyone describe what a line segment looks like? Okay, and actually there you go. So he said it's like a line but has two endpoints. And actually that's a key word there, two endpoints. And the definition we're going to use is kind of weird. I don't expect anyone to come up with this definition. But the key part of the definition is that it has two endpoints. So if you had something like that, there you go. That's pretty good. And most people know what a line segment is, even if they didn't come up with that term, endpoints. So let's go ahead and write this down. Two endpoints and the set of all points on a line between the two endpoints. Again, not necessarily the only definition of a line segment that's out there, but this gets the point across. It covers all the essential properties, and the main idea is that we've got two endpoints that define this line segment. So I'm going to go ahead and draw one real quick. And I'll go ahead and call that line segment AZ. I bet some people in here can figure out what notation we use for line segments. What do you think it is? It's a line with dots. So it'd be like writing line AZ, but instead of that, you can write it two different ways. You can either write it with the dots on the end, but then you have to sit there and you have to like draw these little dots. More likely what you're going to end up doing is AZ just with a line over it, and don't draw arrows. Okay. Does the order matter when we name our line segment? Generally speaking, it does not matter. So we could call this AZ. We could call it ZA. There are reasons why you might want to name it one versus the other. there will be a time in class when you do have to name it a specific way. But that's not till next semester. We might squeeze it in at the very end of this semester. But anyways, there's going to be one time in particular where you do have to name it a specific way. But besides that, it doesn't really matter. Okay. We don't need to add anything here for example / explanation. But these are your terms that you need to know. And before we move on to the bottom of the page, I wanted to kind of give you some hints because we're going to be testing on this, and that'll be in a couple weeks, I think. And you will need to know these definitions. You'll also need to know the undefined terms up at the top of the page. So point, line, and plane. But you need to know these definitions. And if you're sitting there thinking you have to memorize the definitions, well then you're stressing you're stressing yourself out more than you need to. Just remember some important ideas. For a line segment, we'll start at the bottom and work our way up to the top. For a line segment, the key idea here is that we have two endpoints. All right, so I'm highlighting that one concept. If you want to underline it, put a box around it, put a star next to it, something to kind of highlight. This is the important idea. If I remember that a line segment has two endpoints, all the other words in there, are just kind of extra to fill in the blanks, to kind of fill out the rest of the concept. But that's the main idea. The main idea with perpendicular lines is that we have a right angle, an intersection at a right angle. So you don't need to waste your time trying to remember exactly the phrasing of things. Just look for these essential ideas. Parallel lines, these are lines that never intersect. And with circle, the main idea here is that all the points are equidistant from the center point. Okay. So with angle, I already highlighted up here vertex, but that common point, that share a common point, that's kind of the other way of saying vertex. So just keep that in mind. All right, so focus on the essential ideas, read the definitions when you get to the test, and use that to kind of piece together what the correct word should be. All right, the last little bit right here, we're talking about rays, triangles, and polygons. The definitions of this, they're already written out. You don't need to have those memorized, or you're not going to be tested on those definitions at all. So for ray, it's just important that you can recognize it and you can use the correct notation. So for a ray, it looks like a split between a segment and a line. You've got one endpoint and then one point along the ray. So I'll call it HI. And I bet you guys can figure this out. What is the notation of this going to be? Okay, HI with kind of the arrow on top. Okay, does order matter here? It turns out for this one it does matter. H is our end point, so it has to be below the end point. It has to be on the left. And I is a point along the line, so it needs to go where the arrow is. And I'm going to give you guys another example of a ray. All right, so let me give you another one right here. And you can go ahead and write this down on your page as well, because we didn't use that box before. So, right there, what would you call that ray? Okay, it would have to be IH. And this is one that confuses people a lot, where you're used to writing things left to right, but in this case you have to go right to left, because that's the direction our ray goes. All right, there you go. Pretty straightforward with that. Okay, the triangle. This is going to be important to understand the notation of. You guys know what triangles are, so I'll just draw one real quick. You can squeeze it in that box, I imagine. I'll just call it I'll put points x, y, and z here. And can anyone remember what triangle notation looks like? There it is. Sophia just said it. It's just a small triangle out front. So I'm going to have a triangle right here. And go ahead, someone name this triangle for me. What's it going to be?
XYZ.
XYZ. What else could it be? YXZ. That works. ZYX. I'll write that one, and then you guys can, if you want to, you can write all the possible names. You'll obviously only have to write the name once. And I will say a couple of things about the notation here. First of all, there will be times that the name of the triangle has to be something very specific. You can't just call it XYZ. It has to be XZY. And when we get to that point, I'll explain it, and I'll make sure I really dwell on that. But sometimes the order does matter. For right now, it doesn't. Another thing, the most common mistake with this, besides naming the triangle incorrectly, sometimes, is using the wrong notation altogether. When you mean to write triangle XYZ, you accidentally do this. Angle XYZ, and vice versa. So if you're trying to talk about an angle or a triangle, make sure you just take the time to look at it. Make sure you drew the correct symbol in the front. If I see the wrong symbol and I'm asking for exactly the name of the triangle, then I will count it wrong. Okay? So it just takes, a split second to kind of stop and be like, okay, this is a triangle, so let me draw a triangle. All right. And the last one here is polygon. All right. So a polygon, you see the definition. It's any closed shape with 3 or more segments making up the sides. So a triangle is the smallest polygon we can make, but it goes up to many, many-sided. And when you are talking about a polygon, let's skip past the triangle for now. But when you're talking about a polygon, let's go ahead and draw one. Then we'll figure it out from there. So I'm going to draw a 5-sided polygon real quick. Okay. It doesn't have to be a pretty one. Just draw something like that. And make sure you go ahead and name it. I went around and named it A, B, C, D, E. So the notation for your polygons is just going to be the name of the polygon, what type of polygon it is. So what would you call this 5-sided polygon? Pentagon. Okay. So we would say pentagon. You could abbreviate that to P-E-N-T, but I'm going to write it out. So pentagon. And now when you're naming it, you don't just get to pick any letters you want. You have to start at some letter and either choose to go clockwise or counterclockwise around in order. So the easy way of doing this is start at A and go around clockwise, so A, B, C, D, E. Another completely legitimate way of naming this would be pentagon D, C, B, A, E. So if I started at D and went around counterclockwise, D, C, B, A, E, that works, it just looks weird. What you can't do is just jump around and be like, okay, this is going to be C, E, A, D, B. You don't just get to pick the order for any 5 letters. So does that make sense, how you name these? Okay. Now, the one thing that, if you're thinking about this won't come up in our class, but if you're thinking about this, what if you have something that's like 40-sided? Like, do you have to come up with the name for a 40-sided polygon? There you go. So at that point, you don't worry about a specific name for it. You just call it, if it's 40-sided, yeah, it'd just be a 40-gon. Now, this, if it comes up in our class at all, it would only come up a couple of times, but actually it might never come up. Because everything up through a decagon and a dodecagon we'll generally refer to it, that's 12-sided. That's about as big as we'll ever get in this class. But it's just kind of a side note, I guess, more than anything. All right, and those are the notation. Just one last time to reiterate this point. What you're going to need moving forward. You'll need to know the definitions when we do our test. You'll need to know those undefined terms, point, line, and plane. But moving forward for the whole semester, the whole year, you're really going to need to know the notation, especially for triangles and angles. And of course, angles or segments and lines come up quite a bit too. Most of that stuff you just need to recognize. So what we're going to do is we're going to get some practice with that now.